diagrams. So last year, you probably learned about set notation already. You don't have to write this part, but you might have seen something like this: x such that x equals 3. So if you're solving an equation, or maybe a system of equations, or looking for the solution for a graph, you might have written a solution set like this, where it's basically saying all the x values that are possible for that equation. It's kind of the same thing. You're just writing out all the possible values that fall into that set. So, first off, Venn diagrams represent the relationships between multiple sets of elements, and specifically we're going to talk about elements that are in common between those two sets and ones that are distinct to just one set. So, when we're listing out elements in set A, we're going to include anything in this circle. That includes stuff that's in the intersection. We're including some things that are in B, but it's anything that is in the A circle. So that's 3, 6, 9, and 12. Typically, you write those in order from smallest to biggest. If you happen to not do that for me, I don't care. As long as you pick out all the right elements, the order shouldn't really matter, but typically you will see it smallest to biggest. Everything in set B is all the even numbers: 2, 4, 6, 8, 10, 12. That makes up set B. And the universal set is everything in A, in B, and the stuff that's outside of A and B. The stuff that is not in A and B. So it's really just all the numbers 1 through 12. All right, we also want to talk about a few words dealing with Venn diagram and how we write those in set notation. First one is the union of two sets. Union means we're putting those two sets together. Anything in A, anything in B, and anything that's in the middle. So anything in either set or anything that's in both sets. Stuff out here is in either set, that's either A or B. Stuff that's in the middle is just in B, that's in both A and B. All of that stuff is included. We're putting those two sets together. We have two different symbols that really mean the same thing. That symbol and that symbol, they both mean or. So in set A or in set B. All right, the intersection of two sets contains only the elements that are in both sets. That is specifically in that overlapping area. Those are elements that are both in A and in B. So this is saying it can be in either or. It could either be here or there. Both also works. When I say set A and B, it has to be in both at the same time. It's got to be in that intersection. And these are our two symbols. We have that upside down U, and then that caret symbol. Both of those mean and. Most of the time, when we're talking about Venn diagrams, we're going to use this symbol. Later, when we talk about logic, we typically use this symbol. Not sure why we have the different notation, but they both mean the same word. They both mean and. The last one's called the complement. The complement of set A contains everything that is not in set A. So we have set A here. Everything outside of there is shaded. That is noted with an apostrophe. A with an apostrophe means not set A. Everything outside of that A circle. All right, let's try a couple together. A and B. We're looking for specifically stuff that is in A and B at the same time. So that is 6 and 12. It's got to be in that overlapping area, just 6 and 12. B or A. Anything that's in B or A includes all of these underlined numbers. Anything that's in A, anything that's in B, those two groups put together. So that's 2, 3, 4, 6, 8, 9, 10, 12. The complement of A, that means not A. Everything outside of this circle, that includes some things that are in B, and everything in the outside. Doesn't include the 6, 12, or the 3 and the 9. Those are all in A. So 1, 2, 4, 5, 7, 8, 10, and 11. Next one is not B. That's the complement of B. Everything outside of that circle, that includes all the things that are outside both, and the things that are exclusively in A. These do not count because they are in B. So that's all the odd numbers. 1, 3, 5, 7, 9, and 11. Now we're looking for things that are in A and not in B. In A and not B. I'm writing this symbol now just to make this a little bit easier for myself. This tilde is really another way to just say that. That means not. It's kind of the same thing as what I was describing before. Typically we use this with logic, but I just wanted to shorthand. These all really mean the same thing. It means not that thing. Not B, not B. So we want to know stuff that's in A and it's not in B. So it's got to be in A. It has to be something that is in this circle, but we don't want to include the stuff that's in B. So we're going to eliminate the 6 and the 12. It's just 3 and 9. Those are in A and they're not in B. When we have parentheses around this, this has a different meaning. This is saying the stuff that is in A and B is going to be excluded because we're not talking about those things. So first I want to figure out what's in A and B. The intersection between A and B is this section here. That is A and B, but this is saying the complement of that group. The complement of that means everything outside of that intersection, so just not 6 and 12. We're going to include all the numbers aside from 6 and 12. All right, last one, not A or not B. All right, this or means we're including anything that's in this group and anything that's in that group. Either of those two conditions need to be met. Either it's not in A or it's not in B. So let's pick out all the stuff that's not in A first. Everything outside of A. That's everything outside that circle. That is automatically going to be included in this because we're talking about either or. If this condition is satisfied or if this condition is satisfied, it's an element in this set. So everything outside of A, that's everything on the outside. And the things that are in B but not in A. The second part of that is saying we could also be okay with anything that's not in B, so anything outside of here, which includes the 9 and the 3 that are in A. Now, this part I think is confusing. When you see this, not B, you're thinking we can't possibly be picking these ones because those are in B, and it says not B. But it's saying either or. We don't need both of these to happen at the same time. It could either not be in A or it could not be in B. Either of those two conditions mean we have an element from our set. So it's everything besides the 6 and the 12 again. These end up as the exact same answers. If you want to do this, you can. I don't prefer this. I like thinking about it like this. I think about what's in the set, and then I just pick out the things that are not there. But if you'd like to, you can imagine distributing this. It goes to the A and the B, and we flip this sign over. Instead of upside down, it'll be a right side up U. These are identical. Logically, these two notations are the exact same thing. All right, now we're working backwards. From a shaded Venn diagram, we're trying to label what is this section. So the first thing I'm seeing is that it's the stuff that's in between A and B. It's the stuff in between A and B. So that's A and B. But it doesn't include all of that. It excludes this part. So it's A and B at the same time. It's got to be in that intersection. It's not or because we're not including stuff on the outside. We're just including the intersection, so it's and. And it's also not in C. It's the stuff that's in A and B, and it's also not in C. That section is completely in A, so I know A is going to be a part of it, but we're excluding these parts, which are a part of B and a part of C. So we're going to say A, and it's not in B, and it's not in C. We excluded these parts, that's why I'm saying not those parts. All right, now I see stuff that's in A exclusively, B exclusively, and the intersection. That's saying we're putting those two sets together. That's either A or B. Anything in A or B works, but we're not including those parts, so and not C. It might help to write it like this. Maybe that just helps you logically think about it, that it's A or B, and afterwards we're also getting rid of the stuff that's in C. Logically, it's the same. Oh, whoops, I guess I skipped. Well, alright. When I clicked next on the smartboard, it jumped down to this part, so we're going to consider that part of the notes. I'm just going to go up and, I'm just going to continue and do the top section, this you try, you got that part, and then you'll just do these last two on your own. These are actually a little bit simpler than what we just did. Alright, so A and B, we're looking at the intersection. That is the overlapping area in between A and B. This is saying A and not A or B. Okay, so it has to be an A, and at the same time, it's not in this group, A or B. I'm going to shade those two areas with different colors and see if there's any overlap. So I'm shading A. And then I'm going to shade anything that's not in A or B. Now, A or B is anything that's in these two circles together. There's nothing intersecting there. There's no section here that's both shaded with blue and red lines. So we're actually not going to shade anything on this one. This is called the empty set, or for right now, we'll just say no solution if you want. You can also actually write this in set notation. Either way, for right now, we're just not shading anything because there's no intersection between those two groups. Number 3 is saying, actually, we kind of already did this part. It's just this part of this. We're going to pretty much just ignore C. It's saying A or B. So it would be anything in here, anything in A or B, but we're saying not that. So everything outside of A and B. And it happens to include some stuff in C, but we're ignoring that completely because we're only relating A and B here. A and B, but not that. So actually, I'm going to figure out A and B first. That's what in the parentheses is talking about, but it's really saying not that. So everything outside of this section, or it could be in C. When you see this or, that means we're including everything in this group and everything in this group. So I'm going to do this part first, A and B, outside of there. Oops, that's a little too much. Outside of the intersection. So we're not shading in this section so far. Or it could be in C. So we're going to end up shading anything that's also in C. That's including that little section there. The only part that's not shaded is this little section here. Last one's together. You know what? I'm sure you can try this on your own. Try your best. If you need help, I'm right here. Ask for help.